Good day, I'm Southey from Stellenbosch University, and today I'm here to discuss the climate and terrain tool for the Elgin, Grabo, Fairboom, Villiers-Dorp production area specific to pome fruit. I'd just like to contextualize that this project forms part of a larger WineTech funded project called the TERRACLIM project and can be viewed at terraclim.co.za, where the focus is for all the wine producing areas to disseminate climate and terrain information at the highest possible resolution to aid long and short term decision making. And the nature of this project has required a significant amount of research and development, which is being funded by WineTech. So this study area that was selected based on the weather station distribution data provided to us by iLeaf. And the aim of this project is for you as the end user to have access to terrain and climatic information all the way down to farm and field level. So if you select in a specific orchard, you can get the terrain information such as slope, elevation, solar radiation, as well as climatic information at an hourly, daily, and monthly resolution. And that transitioned into bioclimatic indices and long-term contextualization of long-term layers for that specific area. And then within this region, for you to have access to we create a graph within this report that gives you access to climate information that compares this season to the last 5 seasons, which also makes it a tool that can aid in-season decision making. So within this tool and within this WineTech funded project, as well as the Hortgrove funded project, we have aimed to improve the resolution from 90 meters to 2 meters. That can improve spatial decision making. And then for temperature, it's been a little bit more complicated, as that has been very dependent on our sparse and irregular weather stations throughout the Western Cape. So we have focused largely on building a centralized climate database and transitioning the climate mapping from 1 kilometer to 20. And for the specific study area, we've been able to take it to 10 meters. So within this research project, a lot of focus was put on the centralized climate database and how to ensure that the data that's going to be used to create the spatial maps for the specific EGVV area is of the highest possible resolution, clean, and gap-filled. And then that information is transitioned into interpolating wall-to-wall climate surfaces. And as you can see on the right-hand side, that is a wall-to-wall climate surface. So it's taken the points and created a map for 24 hours of the day, for 365 days of the year, for five years. And this information is then transitioned and hosted on the online GIS platform called terraclim.co.za, where we disseminate the temperature and the terrain derivatives. But furthermore, you take all this temperature information and you create the bioclimatic indices and threshold mapping that can aid in-field decision making. And on the left-hand side, you've got an example of growing season temperature map from 2015 to 2020, how it shifts spatially. And then here on the right-hand side is a threshold map for hours between 35 and 40 for a growing season. So it gives you an indication of where the cooler and the warmer areas are, and this can be used as a prediction tool as to when we can expect the next expression of flowering. This TERRACLIM tool is what it looks like online. It's very easy to navigate and use. As you can see, it's very similar to Google Earth. We have opened up a tab for Hortgrove area specifically, and if you go, as you zoom in, you get your farm areas, which is the orange highlighted, and then the green highlight, which is actual vineyards and orchards that are surrounded. You can put on rivers and different functions, such as dams. And the more you zoom in, you get a description, an idea of what the temperature looks like. Cooler areas, warmer areas at a specific farm level. Then if you select on a specific field, you get a report that's generated that gives you all your terrain information, your climatic information, and then lastly, the graph that gives you an indication of this season's temperature compared to the last 3 or 4 seasons. And that can aid in-season decision making when considering how is this season compared to previous seasons, and how does that link to what you're seeing in your orchards. And then all of this information is disseminated into these growing. This is an example of daily positive chill units transitioning from 2015 to 2020, and a zoomed in version of that. And spatially, you can see how the chill unit shifts from year to year, and that can aid us with in-season and long-term decision making. And that's very much summarizes the TERRACLIM tool specific to the EGVV area. And for this project, I'd like to thank the team, and I'd like to thank WineTech for funding it, Hortgrove for funding it, and taking us on board for using this tool in other agricultural sectors. I'd like to thank iLeaf specifically for all their inputs in data provision, and GeoSmart for providing us the 2-meter digital elevation model, which makes this high-resolution temperature mapping possible. So thank you very much for your time for listening to this, and I would greatly appreciate any feedback on the TERRACLIM tool and how to move forward specific to the pome industry. Thank you.